Okay, folks, here comes problem number 6. We said on this problem, since it's a 1g squared, that we can guarantee that we got a g here and a g here. And this makes our problem a lot easier because when we think about what two numbers multiply together give us negative 27 and add together to give us negative 6, it's going to just flat out give us the answer when we can come up with the factors right in here. And so I see 3 times 9 is 27, right? But I need a negative 6 when I add them together, right? 3 plus 9 added together gives me 12. But one of these two has to be negative. So I'm going to make the 9 negative so that I have a 3 plus a negative 9. And that would give me the negative 6 right there. So I come down here and I put g plus 3 and g minus 9. And I'm done at that point. I mean, that's all we need to do on these kind of problems. These problems are more difficult because what we're ultimately going to do is we're going to separate this middle term, and we're going to write 5x squared, and we're going to have a 6 at the end, but we're going to break this 17 into two separate terms that will add together to give us 17. So let's put this up here in our table. See, we're going to have them add together to give us 17. Now, they don't multiply together to give us 6. This is kind of the weird part. They multiply together to give us 30. We got to multiply these two factors together here, and I'll show you here in just a second what's going on here. So when I think about 15 times 2, 15 times 2 gives me 17 when I add them together. And then what I do is I come down here and I say, okay, well, 15 and 2, see how that those two factors of 30 add together to give me 17 right here. So I'm going to put down 15x plus 2x. And what it's done for us is it's set it up perfectly for factor by grouping. So what I need to do is I need to figure out what the GCF between those two is. So let's figure out the GCF real quick. All right. So I'll write down 5x squared. I'll put down 15x, and I'll say, okay, what are the factors of 5x squared? Well, 1 times 5 times x times x. What are the factors of 15x? 1 times 3 times 5 times x. Okay, what do they have in common? They've got a, 1, but we don't really need that. Oh, they got a 5. Look at this. The 5s are in common, and the x's are in common. So I'm going to write my GCF as 5x, okay? The next thing I do is I put my 5x down, and I put a set of parentheses, and I say, well, what's left? Well, there's a 1x, and then there's a 3. So I'm going to put x plus 3. Those are my terms that I would multiply 5x by to get me back to 5x squared plus 15x. Now, I'm not going to distribute this through because that'll just get me back here. That's not what I want. What I want to do is I want to factor this guy right over here, these two. What is the GCF of these two terms? And I can see that it's 2 without doing this work right down here. So what I'm going to do is I'm going to put down plus 2. And then I also know a little trick about factor by grouping. There has to be the same factor right over here. So there has to be an x plus 3 factor right there. Now we can test it out to make sure we've done that correctly. 2 times x is 2x, 2 times 3 is 6. Yes, it's worked correctly. And now I've got an x plus 3 factor in both those terms. I know they look a little bit complicated, but this is really a term. And then this is a term, and they have an x plus 3 factor in common. So that's our GCF. And then I have a 5x left, and I have a 2 left. All right. So that's how you factor number 6. I can understand missing number 6. It's probably the hardest problem on the test to keep all that stuff straight. How does that all work? Let's go over to problem number 7A and B real quick. Okay. So here was our whole test. Here's 7A. These are patterns that we tried to see. If I take the square root of 121y squared, I get 11y. If I take the square root of 49, I get 7. I have the difference. Yes, that's required also for this pattern. Difference. It's got to be the subtraction going on in there. And then I take 11y. I go like this, 11y, and I put the 11y in the first spots of two different binomials. I put the 7 in the other spot, and we change signs. We go plus and a minus. This is the pattern that we saw with the difference of two squares, okay? This one stands a chance at being a perfect square trinomial. What does that mean? Well, I have 4a squared, square root of it, that gives me 2a. I take the square root of 49, that gives me 7. Check mark. Both the first and the last terms are perfect squares. when I multiply 2a times 7, I get 14a. If I double 14a, let's see, double 14a, that gives me 28a, check mark. That's my middle term. This thing over here is definitely a perfect square trinomial, which means it is something squared. Perfect squares are they're numbers that are generated by another number squared. Let me give you an example. 25 is a perfect square. It's equal to 5 squared. It's a number that's generated by taking another number squared. So this is a perfect square. Now, when I add the words trinomial, or the word trinomial, it makes it sound a little bit more complicated. Perfect square trinomial. Well, a trinomial is just 3 terms. That's all I'm saying. So 2a goes in the first term. Oh, shoot. Let me try that again. 2a goes in the first term. 7 goes in the second term. And we put a plus in between the two. You take whatever the sign is in front of the middle term. This binomial squared is going to generate this trinomial that's a perfect square. All right. I hope I made all that clear. Thanks for doing the test corrections. I need you to work on some ALEKS now. Thank you. 2 topics today in ALEKS. Or if you have a knowledge check, I'll give you credit for working on the knowledge check in class for your ALEKS today. Thank you.